But yeah, thank you guys. It was interesting to hear what you were working on. I was curious about you were mentioning data reduction. So can you just briefly say what you mean by that? Just maybe somebody.
Yeah. So usually when you make an observation with a telescope, there are multiple sources of noise. There are three prominent ones called bias, dark, and flats, and both have different sources, which is actually what we're learning in observational astronomy. So I'm just learning that. But essentially, you have to do some operations to get to your final real data, so to say. So you have to subtract some noise. You have to divide, etc. So that's essentially data reduction. And as you can imagine, it is relatively easy to automate if you say you give these files and then you apply these operations. It's pretty good to automate. Yeah.
But that's thank you. And also, I was wondering. So you were mentioning this database that is online and available for anybody with the internet connection.
Yeah.
So can you give, for example, one example of what with that data? Like what could a person maybe do or see?
Well, it's you can do anything you can imagine, I guess. To be specific, sorry, it is just the header, so it is the metadata for the moment. Maybe that will be a future project to also actually make the data itself public, but for the moment it's just the metadata. So you will so that's like the location, when it has been observed, the camera, the temperature at which it has been observed, the angle, etc. So it's not the actual data yet, but for example, if you're doing a bachelor project or any other project and you're interested, okay, I want to see object X, and then you look in our database, or if you have access also to the actual data, of course, if observations have already been made in there, because then it's you can already get started with that data and you don't have to make your own observations, which can take time, and also other people probably want to observe. So it's we can reuse our data that way, because as Ruud already said, it has been 10 years of data collection, and at the moment it's very hard to get a good overview of that. Yeah.
And also, I think Ruud, you said that basically the data is written on the paper. So
I remember also when I was doing observational astronomy. So a lot of the data that we've collected over time is also just on paper. So we literally just need people power to be able to read what was written and to put that on online databases, so you can do a lot more with it. For example, like we wanted to do, we want to make this data available for everyone by putting them in those public archives and databases. So those are one of the steps we then have to take.
Yeah, and people can actually contribute, right? With the Zooniverse, they can actually help us figure out what has been written in those log sheets. So I mean, if you we want to help,
we can share that link because I think you can already help from there. So
okay, so basically you're saying that everybody can help with this. So even if they don't have astronomy background, they can as well help, right?
Yeah.
Okay, that's great. So then we'll share this link as well. Sorry.
Yeah.
It's figuring out what has been written, right?
Yeah.
So log sheets have been made, and not everyone's handwriting is visible for a computer.
Yeah.
I don't say it's bad or good, but it's not always recognizable for a computer. And that's that's it, right? Very much. But it's very useful to us. Yeah.
Okay. Can I also just hear what was your favorite part of this course and doing this?
The observational astronomy course.
Yeah.
Yeah. Well, we're actually still working on it, or at least I am. Ruud has taken it last year, I think.
Yeah.
But for me, it's very weird because we haven't actually been in the observatory. We will hear more about that, but it's actually really fun to make your own observations and then also use that data. And like, for example, our project was to look at asteroids, and now we're actually measuring brightness of these asteroids and then comparing them, etc. And that's actually it's really fun to actually make your own observations, you gather your own data, and then also do something with it.
Yes.
Yeah, I remember last year as well when we actually got to work with those telescopes. That was by far the most fun part of that program. And I still remember it, like that night, working the whole night on getting that data. That was just why I did the program in the first place.
Yeah.
And also you had this nice possibility to actually be there.
Yeah. I do consider myself lucky. Yeah.
Well, yeah. Hopefully, through the PAC, we will be able in the future to actually make some actual observations.
There's possibly more projects with PAC as well, where you can use the telescopes if you want to.
Yeah. So for first-year astronomers too, it's a really good motivation to join us.
Yeah, definitely. Okay, thank you guys a lot. So now we move on to the second talk today.
Yeah.
So yeah, virtual clap again.
Yeah. Okay. Thank you very much.
Thanks.
Thank you, and see you also later, of course, in our virtual pub.
Yeah.
So
Definitely.
now we have our next speakers, which are Anna Esselink and Maria Juba, and they are both first-year bachelor students of the observational astronomy course, and they will be in isolation, the student perspective. So here you go, girls. Here you go, girls.
Okay. Well, hello everyone. Anna was going to something about experience, the online version of astronomy. Now the course is organized and offering remotely online. So first some general information about how the course observational astronomy is organized. Each week we have lectures, topics, astrometry, telescopes, optics, spectroscopy, just name a few. And then everyone get an assignment. Of course, this is the interesting stuff project we have to do within our group. Each group consists of 4 people have to do a project, which is observation night, data analysis, the data that was obtained that night. And in the end, we'll all have to do findings, about the project. In a moment, Maria will tell you a little more about the project that we are doing. Of course, considering the current situation, this all didn't go the same for us as previous years. About a month before the started, the university closed, so we never had any physical lectures whatsoever. This still meant that we couldn't physically for observation night. Being on a Zoom call, observing at night, and as can be seen in the schedule here, each night is invited to shifts, so each night to observe, and we're very lucky with the weather. 8 nights in a row, the weather was great, so all groups had a chance to observe immediately the first time, which meant that there was no replanning needed, which is something that's really unique considering the weather of the Netherlands. And Maria and I were in group 9, so you can see that we were in the 8th night for Jake and Derek. But almost all groups have a different project and are looking at different objects. And to give you a little bit of an idea of how what such a project looked like, Maria will tell you a little bit about that now.
So our project was on nebular extinction of the galaxy NGC 5907. And actually, it's the galaxy you're seeing in the background of this presentation. So what we're doing, we took a edge-on galaxy, which means that it's not you're not seeing from the flat part, as if you imagine it like a disk, but from the side. And it needed to be high in the sky during our observation time. So we first Googled some galaxies which were edge on, and then used Stellarium, a program that shows all kinds of stars and galaxies, to look at where it would be during our observation window. And then we took images of this galaxy in 5 different filters. Visual filter, blue filter, red filter, and the wavelength of hydrogen in 2 different wavelengths. It's a blue one, H beta. It has a wavelength of about 4,000 angstroms, and a red wavelength, which is of a higher angstrom. And what we're trying to measure is the Balmer decrement. It's the ratio between those 2 emission lines of hydrogen. So what we're trying to do is measure how much H alpha there is in comparison to H beta. And this is the Balmer decrement. The higher this Balmer decrement is, the more there is H alpha compared to H beta, which tells us there is more dust, because dust scatters blue light more than it does red light. So the higher the Balmer decrement, the more dust there is. And this tells us something about star formation, which tells us something about the age of the galaxy. It can tell us something about optical depth and many different things. So what were we actually expecting from this course? Pre-corona, before we had any idea what this course was actually going to look like, I had the idea we would be really hands-on. And that would be sitting there, pressing the buttons, moving the telescope. It would be completely us. And I kind of imagined it like this scientific slumber party with a couple of my friends. But post-corona, we were told that it would be online. So the idea I had would be that we would still be leading the actual observation. That our Professor Jake and the TA Dirk would be sitting there while we were telling them what to do. So, hey Jake, can you please focus on this galaxy, press this button, start the observation. And I also expected that we would have way more preparation time, that we would be way more knowledgeable about how the telescope works and how such an observation is actually run. But reality was a little bit different, as it always is.
So of course, the actual observing night was very different from what we had imagined a few months ago. And yes, it has already been 2.5 months since the university got closed. Time is really flying by. But since this is such a unique situation we're in now, it was still very hard to imagine what to actually expect from the observing night. Only the day before, as Maria just said, we got some information about the project. And so we had one day to choose the actual object we were going to observe, and had a little meeting with Jake about our object of choice. And for the night itself, we were in a Zoom call with Jake and Derek, who were at the observatory for about 5 hours. So we could, and they also had several cameras installed, as you could also see here on the slide, in the control room, so we could exactly see what they were doing, and they were sharing the screen so that so we could see and they could explain what they were doing. And mainly in the beginning of the night, of course, they had a lot to explain about how to correctly set up the telescope and how to take an actual image with it. And eventually, so we then started taking the images. Eventually, after an image was made with each filter, we could actually do something ourselves, because we have direct access to the data of the telescope. After a picture was taken with the red, blue, and green filter, we could make a color image of our galaxy, which is actually the background of this presentation. So you could imagine that after sitting behind your own computer screen in your room for 1.5 hours for the night, it was very exciting to actually do something yourself and get a color image of the galaxy on your own computer screen. But besides that, the night consisted of a lot of waiting. After we made the first few images, we had to wait for it to get actually dark enough outside before we could start taking images of our galaxy. And then every image has an exposure time of approximately 5 minutes. So then you also just have to wait a lot for the whole night.
So working as a group, how has that changed compared to being in person? Well, we no longer have a moment where we can sit and work together at Kaptein as we used to, either at Kaptein or Leesborg, were really our spots to just work on our homework and do this stuff together. So we have exchanged those moments we can work together for a weekly Skype call. So our group always meets on Monday afternoon to communicate, like, what are we doing, where are we going, and things like that. And you do really notice that communication is key. I think we all notice that working in quarantine, that without communication, if you're not texting regularly, if you're not expressing yourself on WhatsApp or whatever, clearly you do run into problems. And sometimes some people just don't react for hours, they have other things to do, or the Skype is lagging, or someone is traveling across the country by train, so they have to completely get out of the train, get another bus, and things like that. And it's stressful. And another thing about this course is that you can't do it alone. There's a lot of stuff we don't know yet, so you have to regularly ask help from your professor, your TA. And I've noticed in this course, and actually all the courses, that asking for help is a lot harder than it used to be, because I feel I need to struggle for a good while before asking help feels justified. Usually you would just put up your hand and turn around and be like, hey, can you take a look? But now I have to write out an actual email. So before I can actually do that, I feel like I need to have struggled for a couple of hours. I need to have found all the different sources, and I've asked all my friends before I can feel justified to take up my professor's time. And then there's the questions like, how do I ask for help? Do I go to WhatsApp? Do I email? Do I go to their Zoom call? Or do I just go in a corner and cry? Which happens.
Okay, so as we've mentioned, there are some downsides to having observational astronomy online, but we also have to mention there are definitely also a lot of fun sides to it, such as the great amount of memes you can recreate using Zoom backgrounds, or the fun images Zoom creates when it fails to recognize the difference between you and your wall. And of course, there are sometimes parents walking in, or you send a fun snap and you get a judgy comment back from your sister. For the non-Dutch speakers, she said, nice picture, but the people up there look a little bit angry and uninterested. Sometimes you're kind of forgetting that your camera is on, that people can actually see you. And at least in our case, we're a group of friends that were really used to seeing each other every day at university. So we haven't seen each other for like a month, and a night like this is also a really nice chance to just catch up with each other and totally annoy Jake and Dirk with all the talking you're doing, so you get muted by them. But in the end, it's also a lot of fun.
So, conclusion. Things that went badly, things that went well. The actual nights. We were definitely involved, but we weren't actually doing anything. Like, I still don't know how the telescope works, which buttons to press. Like, I have a vague idea, but for the life of me, I couldn't think this is just taking data from the universe or whatever, and doing your project on that, because this is our data now. I feel like ownership of it, and the background you see of this presentation, I use it everywhere now. Like, this is my galaxy, and I'm proud of it. And also group work. we do really miss being able to come together. I think we all noticed that. And time again, it proves communication is hard. Getting your words across like you mean them, making your idea clear, it's really hard. And so I guess we learn a lot from this. And I've also noticed that knowing your professor a bit helps in terms of asking for help. Because I've met Scott and Jake, our professors. I've met them at the Astronomy on Tap, or we've had a couple of gin tonics before. So I feel comfortable just sending a quick text. But I can imagine if you haven't gone to these functions as a first year, you would feel a bit less comfortable with reaching out. So I do encourage all first years to go to these events and get more comfortable with the people at Kaptein, because it's a great community and we can learn a lot from each other. So thank you all for listening. I hope the stream is working well and you could hear us clearly. And we're happy to take any questions you have.
See, especially this image that you actually made, which is always a nice thing to also use for backgrounds. But I wanted to ask you, so you said, I mean, you called it a scientific slumber party, which is very nice, description. But did you feel like you still kind of had that with these Zoom meetings? Although it was probably harder and everything, do you still feel like
it was fun? Like, we were all girls, so we were gossiping a lot. It kind of felt like those slumber parties. And I had cookies and strawberries. I was just munching the whole night through. So it was kind of like that. It had a slight taste of it.
I think it also, like, the factor that we couldn't do much because we were just sitting behind a computer at home also made us talking and having fun a lot more.
And how long, I think that you said it actually on the first slide, but how long did you actually spend not only meeting, but really observing with Jake, being there and working during the night?
That's hard to say. Like, we were in the Zoom call for like 5.5 hours, and we're just really like the first 1.5, 2 hours, it was really mostly working and discussing what we were actually doing. But then after that, it was just a quick question or little comment about what was going on.
In the meantime, we went outside to look at SpaceX going across the sky. So that was really observing. It was observing of another kind.
Okay, that's nice. But you were all at your own homes, so it was really all of you just meeting on Zoom. Okay, so we also have questions because now the stream was a bit better. We will make sure that the first talk is also better for you guys. But so first question is, what is the object in the sky that you would like to observe, if possible? So if anything was possible, let's also include, so whichever hemisphere and...
Like, if anything was possible, I'd obviously like to look at a black hole.
Yeah.
Because who wouldn't? Which astronomer would want that? But other than that, I think I'd like to look at some planets more, because I think you can see a lot of more detail in them than actually just a dot in the sky. I think that's something I would like to look at.
And Joanna?
I also have to agree with Mia. Of course, it was possible. I would observe a black hole. If not, I guess I don't really have like one object in mind. Maybe just some really nice nebula, or maybe a not edge on spiral galaxy. You can actually see the spiral arms and everything.
Yeah. I mean, now we have the image of the black hole. So that would be also, nice to have the easier access to it so that it's easier to see. We also have a question. Was this the first time for you to work with a telescope, or you have some other experience?
No,
this was the first time.
We don't have like a backyard telescope or anything. This is the first.
The first one. So even from the... Okay, but do you also have some other courses at the university where you will go and observe, if it will be possible, where you will use some other telescopes?
I don't think so.
like there is a trip that some students do. I'm not really sure if it's all of the students where you go to La Palma, so you observe there with the telescope, for example, you stay for a longer amount of time.
Like I heard like down the grapevine that was cancelled. Maybe I'm not sure. I don't believe we have any actual courses where we would use the telescope again. I would love to, but
No,
Yeah, but
maybe
it's also
just
nice to get the
go and
beginning.
be more active at the practical astronomy crew, I guess.
Okay. Then also, did these observations that you did now, did they push you more to go towards observational astronomy, or you're also interested in theoretical? So how did this experience kind of influence you?
I don't know. Didn't think about that. I think I still quite interested in like the theoretical part of it, but it's good to have all of the experiences, and maybe in the future I will in fact look more into observational because it is quite interesting, and I don't think it was never an option or anything.
Yeah, I must agree with Maria. I also find like it was really fun to do this once, but I don't know, means that I'm more leaning towards doing observational astronomy right now. So theoretical is also very interesting.
Yeah, I mean, it's also very early to say at the beginning.
We've
Because
just started.
if
So.
you study astronomy, you just like it. So you will find out throughout time what you prefer. But it's nice. Thank you a lot for your talk as well.
Thank you.
So now we go to Jake. We go and we do one round of the pub quiz, and then later you can all join us in Zoom and talk to our speakers and to our organizers as well. Thank you.
Hi there, everyone. And sorry for the technical problems we've had so far. We'll move into lag video. How but I'll start the quiz and you can join. So wait for the stream to catch up. It's going in real time. That's a bit of a problem. But in the quiz, as usual, I remind you that so there you go. There's about a 20 lag, but please start joining. I don't hear me at all. Now I hear me. So hopefully you can hear what I'm saying now. And the lag is about 20 seconds between the screen and the quiz. So please make sure you answer as quick as you can, because the last 20 seconds of the countdown and the question is probably too late. We're sorry to say, because things move along, and apparently today in YouTube we can't avoid the lag. And 1 more minute till we start. And we're into the 20-second zone. I hope you've all joined who wants to join, because quiz is going to start now in 5, 4, 3, 2, 1. And here goes the quiz. The sun and planets move along a path in the sky called what? The equator, the ecliptic, equinox, or solstice? Hope some of these guys who've been talking to us earlier know these answers. I hope everyone else does. See, Scott is there. See if he's quick on his clicking, or maybe he can be beaten by someone else. Oh. Sorry, I was hiding some of the answers, but I wasn't hiding the right answers, so. And there you have it. Yes, the ecliptic is indeed what we call that line that they move along. Oh, and who would guess Scott is in the lead of the observational astronomy quiz? I'm sure that if he wins, he's going to donate his prize to a very good cause at the end of this. Question 2. How many solar system planets have rings? 1 planet, 2 planet, 3 planet, 4 planet? Yeah, all 4 of the outer big gas giant planets have rings, including Uranus and Neptune. Both also have rings, not quite as fancy as Jupiter and Saturn. Well, Jupiter's not really that cool either, but they do all have rings. I'm sorry, guys, but I'm letting you know that you probably have about 20 seconds in the countdown before the timer stops on your phone or app, whatever you're using, between when I put the question up and when you answer it. So just know for that you've got about the first 20 seconds of that countdown from 60 to 40 to get your answer in. Let's see how that went. Scott's still up there. Other people could still win, though, so come on, work on it. Click as fast as you can. There's our description. All four of the giant gas planets have rings. You can see right there. For a telescope, a good observing site should be which of these things? A place with good weather throughout the year, high up and have a stable atmosphere above it, away from towns, or all of the above. I notice that some of you answer before it's even possible that you've seen the question, so good luck with that. Indeed, all of the above. So, if you answered one of the other answers, you're also right, but all of them are important to consider. Some towns try to work on it. We have a student working right now on her bachelor project about how we have light pollution around this area and how in the Dark Sky Park in the north from here is going to be a good site for people to go and try to observe. So hopefully we get all of those conditions. We won't get good weather throughout the year, but sometimes of the year we do, and certainly don't have the stable atmosphere, and we're not very high up. But up there in the northern Netherlands, we could be away from the town. How's it going? Oh, people are charging upwards. Next question, looking at the image, which of the following is true? Star B is hotter than star A, star B is cooler than star A, stars A and B have the same temperature, or one can't tell from that. So I see no one's answered in advance this time. That's getting more legitimate. I'm sorry that you have to wait just listening to me talking about things. But you can look at these stars, enjoy them. Then, hopefully in about 10 seconds time, you'll all be able to answer, which is then, as for me, the last 20 seconds of the countdown. So I wish I could count you into that, but I can't because it's already too late. But now you'll get this at the beginning, I guess. There it goes. Here's the question up on your screen, and answer as fast as you can. You got 5 seconds left now. All right, so exactly, star B is hotter than star A. And you can tell that from the color. I think we have a slide explaining that next, after we see who's doing well. People climbing up. Can people get above Professor Scott? You know, he does use his Kahoot all the time in class, so should be good at it. There's the famous Hertzsprung-Russell diagram, so you can see the hottest stars are the more blue-white stars, the redder stars are colder. For some reason, we label our taps the different way around, with red being hot and blue being cold, but that's not how things are when they're hot. Next question, which is the furthest object visible from Earth with the naked eye? And here the countdown starting. I'm going to try to guess this time when we get to that 5 second mark. I guess now you probably have 10 seconds left to answer. Now probably 5 seconds left to answer. And now probably you should have answered, and you could just listen to me talking about the Whirlpool Galaxy, Antenna Galaxy, Andromeda Galaxy, or the Cosmic Microwave Background. As I guess at this point you already had to answer, I can tell you a really cool thing is if you have night vision goggles, such as the US Border Patrol does, as I learned in Arizona one time, that if you use night vision goggles normally used for finding people crossing the border from Mexico into Arizona, if you actually point them up at the Andromeda Galaxy, you can see how big it is, and it is much bigger in the sky than the moon. It's just a lot fainter. But with the IR goggles, you can certainly see it. So yeah, you're right, Andromeda Galaxy is the furthest thing that you can see with your naked eye if you're in a very dark place and ready to see it. See who's doing well. Scott's still up there. Everyone else is still in play. Just keep those clicks fast. Fast answers, accurate answers. That's what it's all about. So which motion of the Earth causes the designated North Star to change over time? Well, we've got some choices: revolution, rotation, precession, translation. And now you've got probably about 10 more seconds to answer. Now about 5. And now when you're seeing this, you probably should have answered, as the time is going to be ticking down away. But let's talk about those other things in the sky too, that you've got. You do have these different motions happen. Obviously, the Earth rotates all the time. We call a rotation what we do every day. The revolution is the word for what we do in our orbit around the sun. Translation would be moving up and down or sideways, which we don't really do too much. And precession is the one that matters, that if you imagine a spinning top slowly moves around, and we do that about every 30,000 years. And so, again, well done, everyone. Who was fastest, though? That's the all-important question. Whoa, Pima, the best, Lisa, NGC 5907. Come on, you can do it. You can knock this Scott guy off the top spot. Let's go for it. Here's a little explainer again. So the next questions, they're all about name this moon. So there's going to be some moons. You got to name the moon. Again, fast as you can, because even though it says a minute, you just get 20 seconds and then me talking to you. So here you go. Name that moon. So is this moon Europa, a moon of Jupiter, Enceladus, moon of Saturn, Phobos, moon of Mars, Io, moon of Jupiter? 10 more seconds to go. 5-ish seconds to go. And probably you had to answer by now. If not, we'll give you more clues anyway, because you're down there. Io is known for all its volcanoes on its moon around Jupiter, very orangey, yellowy, sulfurish looking. Phobos don't look like this. I won't give too many clues away, because some of these may come up later. And this is, as you'll see in a second, Europa, Jupiter's moon, may have a big frozen or semi-frozen ocean underneath its crust that's constantly pulled apart by gravitational forces from Jupiter. And yeah, most of you got that right. Just slightly most of you. Let's see if you're quick though. Oh, Scott says he's going to do bad on the moons. Oh, the best is already really catching up with him fast. Lisa's got a good streak going. Sten Pima's still there. Let's go, let's go. Let's see the next moons. Name this moon. Again, another moon. This is not a very featureful moon, but is it Charon of Pluto, moon of Earth, Titan of Saturn, or Callisto of Jupiter? Probably 5 more seconds to pick. Now, hopefully you picked. If you think that's what the moon looks like, you can actually look outside in Groningen right now and see the moon. If you've got a south-facing window, the moon is almost exactly south and does not look like that. Callisto doesn't look like that. Charon doesn't look like that. Titan, Saturn does. is a moon which has a very, very thick atmosphere, so we can't really see the surface. But the European Space Agency actually landed a lander on the surface of Titan, the Huygens probe, that was taken there by the Cassini mission, which went around Saturn for a number of years observing Saturn. And then the Huygens probe was released by ESA. The European Space Agency landed on the surface of Titan, saw a lot of cool stuff on its way down, so we understand that better as you got. Scott did still seem to know that moon, but Lisa, the best Pina, and NGC 5907 are all on their way up, so everything's in play still as we continue with 2 more moons. Moon number 12 is coming up here. What moon is this? Triton, a moon of Neptune, Enceladus of Saturn, Iapetus of Saturn, or the moon of Earth? And 5 seconds probably. And 0 seconds probably. So while you're looking at it, does it look like the moon? I hope you've gone outside and looked at the moon in between the 1 second you had between questions. Still does not look like the Earth moon. So could it be a moon of Saturn? Could it be a moon of Neptune? Who knows? It's always good to compare the surface features that you see on these moons. And we have versions of these, a lot of these objects that we also do 3D printing of, as some of the practical astronomy crew guys were saying, so that blind people can also see them in a tactile way, and also other people can get a feel for it as well. So yeah, if you were right, it was Enceladus, the moon of Saturn, with those nice ravines across its surface. Oh, Lisa has leapt into the lead above Scott, but all of these in the leaderboard, and probably some below, are still in the playing for the next, and I see Astronauts is rising up high. I think this is the last moon, and the last question, name this moon. Is that Deimos of Mars, Iapetus of Saturn, Titan of Saturn, or Callisto of Jupiter? 10 more seconds left. Probably 5 seconds left. And probably you should have answered, so in the rest of the time we'll just talk about this moon, which, as we already saw Titan, hopefully not many people chose Titan. Callisto of Jupiter, that's a pretty big moon, so as moons get bigger, their mass gets greater, so the greater the mass, they can become more and more spherical in shape because their self-gravity pulls themselves together. So you have to be a little moon in order that you don't have that nice round moon shape, that you have some kind of other little potato shape. A lot of research is done into whether they're actually sort of crusty potatoey inside, or whether they're actually solid inside and just haven't formed the spherical shape. But yeah, you all got it, Deimos. We did see it too earlier, so good job, guys. The name, at least. So let's see how things have gone. If you are the winner, please screenshot your phone and then claim your prize, which at Buckshot Cafe next month will be a €25 gift certificate to Buckshot. So well done, Lisa, at getting up there at the top. So Lisa, please screenshot and send us the information, or come to the pub in a second and just tell us, and we will get you that when we go back to Buckshot. So speaking of Buckshot Cafe, hopefully we will be able to go back to Buckshot next month. We will be running things from there again as soon as we can. Next month we'll probably be running the event from there, but we may not actually have the event there depending on their current capacity limit at that point. It's also it will be very cool if we're able to get there. It'll be very cool if we can go. So I'm looking forward if we can go back and can run all of this over there, even with just our team all together running it. And then hopefully in the near months we'll be able to get back to Buckshot again, because obviously we support them a lot. They've supported our event in the past a great deal, and we hope that their business gets back too, and it all goes well for them. So here I am gonna say bye to you from here, and then I will join you in our online pub very shortly. So you can go to the link I'll put up right now, which is for our online pub. And so please go visit our pub online. You can chat to the speakers are there. You can chat to our organizing team, and you can claim your prizes from the quiz if you did well in that. And thanks everyone for watching. I hope you enjoyed the evening today. Sorry about all the technical thingies at the beginning, but now we can just go enjoy a drink in the pub. So I hope I see you all there in a couple of minutes. Bye, guys.